Welcome, I'm Carl Tate. The question here is, how many tectonic plates does the Earth have? The first step is to define the plates of the Earth, and we'll see the evidence in the next video on where this comes from. The second step is to name them, and this shows the 12 primary plates of a model published in 1990 called Nouvelle 1. We can see these plates shown here. It's worth knowing these, and fortunately they have names that are associated with things like the continents, but we do not want to confuse the North America plate for the North America continent. They are not the same thing, and we will see that several times. So here they are, the plates of Nouvelle 1. There are 12 of them, and we can immediately see this point that the coastlines and the plates are not the same thing. In fact, coastlines are not that relevant toward plate tectonics in thinking about the motion of these large chunks of material at the Earth's surface. Moving forward, Nouvelle 1 had two additional plates, the Juan de Fuca plate and the Philippine plate. You can see here, they characterize these motions, but they weren't a fundamental part of the model. So here we are with the 14 plates of Nouvelle 1. 4 years later, Nouvelle 1A, we see two additional plates, Rivera plate, offshore Mexico here, and this Scotia plate. So these are at 16 plates. Then in 2002 and 2003, a model came along that was, I would say, radically different. And this is shown here by Peter Bird, an updated digital model of plate boundaries. And I'll quote from the paper. The principal change is the inclusion of 38 small plates, in addition to the 14 large plates that were mapped in the previous version here. Most of these boundaries were proposed and many also mapped in detail in published sources, so they do not represent new research results. Their assembly and digitization was editorial work involving occasional applications of editorial judgment. What I like is it conveys there's judgment involved, but there's an incredible amount of understanding and documentation of a massive literature in order to make the decisions of how many plates there are. And in that model, it jumped from 14 to 52. And so here's the figure from Peter Bird's model. Here we are in Alaska. The colored plates are colored. There's lots of small plates in here. There's also what he calls origins, or regions of the Earth where plate tectonics doesn't work that well, and that the motion of the Earth does not move as a rigid material, but there's actually deformation or crumpling. So large parts of the Earth where there are these collision zones, it's not exactly work like plate tectonics, but for now we can kind of set that aside and just look at the colors here and appreciate that it's divided in like a puzzle piece into 52 parts, with some obviously very large plates like the Pacific, the North America, and then some very small plates such as GP is Galapagos. I won't read through all this, but I want to leave it there for your notes. He describes kind of how he decided what is a plate boundary. And that's a very interesting procedure, thinking about topography, seafloor ages, volcano locations, these earthquake mechanisms from a catalog of earthquakes, and then also previously published boundaries. We will show all of these data. I will be showing all these kinds of data so that we can also see what information was available. And so he says, giving highest priority to seafloor ages, topographic lineaments. Anyway, this is the information used to decide where these plate boundaries are, in a sense, figure out what's a plate and what's not a plate. So here's a figure from Peter Bird's paper to see kind of all this information in place. And here we have a Western Pacific showing this Pacific plate is shown here. The Aleutian Islands, far western Aleutians are shown here. This is Japan. And here's kind of a simple plate tectonic setting. Pacific plate is subducting to the west and to the north under the Aleutians. And you can see these triangles of the volcanoes, but I start there and then you see the full figure. It's a little overwhelming. There's tons of information. We have the legend here, and part of this is kind of familiarity with reading a map and all the information on it. But what we now see is things get more complicated out to the west. We have this color scale, arrows, we'll get to velocities later, but really we're looking at volcanoes, earthquakes, and the color here is showing you the topography and bathymetry in meters. So 0 would be the coastline, and going up in red and yellow would be the higher elevations, and the deep sea floor is going from 0 all the way down into the 9,000 meters below sea level. So from here, there are these 7 types of plate boundaries by Peter Bird's model. We don't need to know all of these, but I'm presenting them. We don't even know a lot of these words at this point, but continental convergent boundary, continental transform fault, continental rift boundary, oceanic spreading ridge. He has 7 types of boundaries, and that's how they are colored. So you'll see here the blue one, there's the simple boundary, it's all blue. Pacific, subducting here. But then there's a lot of these segments are fairly complicated and changing color on short length scales. For us, we need to know there are 3 types of boundaries. There's a convergent boundary, and so 3 of them fall into this category: continental convergent, oceanic convergent, and subduction. We have divergent boundaries, things pulling apart, continental rift boundary, and oceanic spreading ridge. And then we have transform boundaries, things sliding past each other, not spreading apart, not colliding, but sliding past each other. So those are the continental transform and oceanic transform. So some of this distinction is whether the motion or plate boundaries between oceanic crust or continental. But then it can be complicated. So here's this figure from Indonesia. We're looking at Australia here, the northern tip of Australia, Indonesia, is Java, and you can see there's all kinds of different colored, lots of small plates. It's very hard to piece this puzzle together with the information at hand, but this was a big step toward trying to integrate all this complexity into a single model. So back to this picture, we were just looking at this block here in Indonesia, and then also this section from Northwestern Pacific. So here we had the plates of the Earth. That was the 52 plates of Bird shown in our map that we'll be getting lots of views and material on. The plates are all named and given abbreviations, 2-letter abbreviations to kind of keep track of them, not too many clutter on the map. And we can see the plates go from the A's, Africa, Amur, Antarctica, Altiplano, this little plate in South America, Aegean Sea, out here near Greece, Anatolia, near Turkey, Australia, Bird's Head, and so on down to Woodlark and Yangtze. So there's our 52 plates from Peter Bird shown. The next step was to add 4 more. Not a huge step in some sense, but this shows a plate model described with 56 plates, and the 4 new ones were made by splitting apart some of the plates from Bird. There's Somalia, Luandel, we have the Australia and Capricorn plate, and this Sur plate here, separate from South America, and then Macquarie plate at this southeastern corner of Australia. So there's 4 new plates. That gives us 56 plates, which is what we'll be showing most of the figures. So we can think about just the main plates, but the information is there. It's the most realistic perspective of the Earth, but the concepts we want to keep in mind, such as how plates move, what happens at the boundaries, really, you don't need to memorize 56 plates in order to understand those concepts. Takeaway topics: a tectonic plate is a portion of the Earth that is mostly rigid and that has boundaries where relative motion and deformation occur. The exact number of plates on Earth is debatable. There are 14 primary plates. The latest model describes 56 plates on Earth. And there are 3 types of plate boundaries. These 3 types have different names: convergent, going together, or subduction; divergent, pulling apart, or rifting, or spreading; transform, or strike slip. That describes motion of 2 plates passing by each other without convergence or divergence.